Hey everybody, this is Mr. Ainsworth, and if you're going to be taking the Unit 3 retake here, you got to go through some corrections here, and I'm going to be correcting versions 1 and 2 on the same video. So if you're version 2, then just go ahead and use version 1 as a practice one, okay? And that's a requirement. So version 1 is going to go through version 2 for practice, and version 2 is going to go through version 1 for practice. And the way you practice is take out your spiral, graph paper spiral, and do all your practice in your spiral since there is graphing involved, okay? If you are version 2, fast forward it to version 2, do that corrections first, okay? Do them in red, obviously, and or in your spiral, either one. And then, like I said, version 1 does version 2, and then version 2 does version 1 for practice. And then if you show up on Monday and show me evidence, then you could retake the Unit 3 systems test. No problem. But you have to correct first. Okay, let me write this down. Okay, so you guys, there's no mistake here in terms of understanding. You have to correct your test first. So step 1, correct test first. Correct your test first. That's test right there. All right. And you could either do it in red here, okay, or in your spiral. So in red directly on the test or in your spiral. Just redo the problems, okay? It's that simple. All right. And number 2, okay, a requirement here, this is mandatory. All right. Go through the other version. So go through, all right, and practice. That's key now. All examples, okay, examples or problems in the other version. So if you're version 1, okay, I want you to go through version 2. And if you're version 2, I want you to go through version 1. So you have corrected your test once, okay, correct all your mistakes, and then go through the other version with me and make sure you get the practice that you need, because obviously you didn't do well the first time, and this is the second time around, all right? And it takes corrections and practice to get better, okay? Corrections are not enough. I know that from 27 years of experience teaching. So correct your test and then practice and then show me evidence on that on Monday, and I'll see you on retake day. All right. Also, if you have a TID4, take it out because I'm going to back a few things up on the TID4 here, especially number 1 here. Okay, so let's do by hand first. These are both in slope-intercept form. So y equals m times x plus b. Right here, slope's -1/2 and y-intercept at 2, so you start at 2. And then on a slope of -1/2, you go down 1, right 2. So down 1, right 2, and then repeat it like that. Okay, and then draw your line and be accurate. Okay, those that weren't accurate didn't get a good result. So you want to be accurate here. All right, that's not perfect, so let me redo it. Okay, got to be accurate on your lines here. Make sure it intersects right at 2. Okay, so there we go. Now let's get the other line going. All right, slope's 3 and the y-intercept's -3, so start -3 here on the y-axis here, and the slope of 3, well, that means up 3, right 1. Okay, so up 3, right 1, up 3, right 1. If you just step it out, okay, and then get your straight edge, all right, and then go ahead and graph that line. Boom. Right there. So you can see that it's not hitting the grid lines. So I am going to estimate. So it looks like not quite 1.5. It's right here. So between 1 and 2 is about 1 and 1.5 or 1.4. So 1.4, that's my best guess. And then it's not quite halfway either here. So I'm going to say about 1.3, I don't know, something like that, 1.3, 1.4. This is an approximation. Okay, and then I taught you guys how to do it on the TD4. Okay, so let's get the intersection point on the TD4. So go ahead and clear the functions out and let's enter them in. So -1/2 right here. Okay, x plus 2, and then you just type it in. Boom, like that. Go down here to the second one, type this in, 3x minus 3. All right, that's not too hard, and hit zoom 6. Okay, now there's a couple points being plotted here, so I'll tell you what, it looks like I have points that I don't want my stat plot on, so let me go turn my plots off here. Okay, see, so to do that, to turn the plot off, you just go up to plot 1, turn it off by hitting the enter button, and then go back to the graph. And notice that it doesn't look exactly like the one on the our test here, because I didn't set the scale to square it out. So if I select number 5, actually, that should make it look a little better here. Okay, so now the other one should be forming here. Come on. There we go. All right, so to find the intersection, you go second calc. All right, you got to calculate it. My computer is running slow. Come on. Second calc. Hopefully I was going to show this. I don't know why my computer's running really, really slow. Let me pause it here. Okay, so let me try this again. So second trace, which gives you calculate menu here, you want to intersect the line. So hit number 5. And then it asks you first curve, well, that's y1. And it says, what's the 7 curve? Well, that's y2. And this says, hey, put me at your guess. So let's go towards the intersection here. All right, hit enter. And then you'll see the intersection point about 1.4, comma 1.28 or 1.3. All right, so this is very, very good according to the calculator here. I was pretty good approximating. Okay, so use your TID4 to check your results. Okay, now the calculator cannot graph x equals 4. You just have to know what that line looks like. So you have to know that x equals 4, this one right here. All right, you got to find 4 on the x-axis, which is obviously right here on the x-axis here. And if you go right 4 units, I don't care how far you go up and down, guess what? X is always 4. So this is x equals 4. Let me label that x equals 4. And then you have to solve right here, solve for y. So x minus 3y equals 1. Got to subtract x. And you get negative 3y equals negative x plus 1. Divide everything through by negative 3. And you get y is equal to positive 1/3, okay, x, all right, minus 1/3, okay, where the slope is 1/3 and then the y-intercept is negative 1/3. So you plot at negative 1/3, which is, you got to divide up this little unit into 3 equal parts and go down 1/3. And then you got to go up 1, right 3. So you got to go up 1 right about there, all right, right 3. Let me put this in blue here. So right here, up 1, right 3. All right, and then you draw your line. Well, actually, let's repeat that. Up 1, right 3, right about there, okay? And then draw your line from there. So here we go. That's pretty close right there. Right there. Okay, and then you got to ask yourself what this point is, right? I see 4 here, and it goes up to 1, so this point right up there, that's 4 comma 1. And guess what? That makes sense because x is 4, and if you put 4 here and you put 1 here, let me see, 4 minus 3 is 1, okay? So you check the solution in the system. So I take this and I substitute back to check. And 4 minus 3 times 1 equals 1, and there's your check. 4 minus 3 times 1, well, guess what? That equals 1 because 4 minus 3 is 1. So there's your check in the system, and you know you're right. Okay, let's move on here. So you got y equals 3. So you go on the y-axis and find 3. There it is. And then I don't care if you go up and then right or up and left, y is always 3 right there. So you got this horizontal line at 3. And then you got this line right here, so you got to subtract x. And you get y is equal to negative x plus 5. Slope's negative 1. And the y-intercept's 5. So you start up there, 5. All right, and then you go down one right one, and you step it out. And you step out a negative slope. All right, and notice that I just intersected the line right here, the horizontal line at that point, 2 comma 3. So there's your solution. And you can just see it right there. Okay, so draw your line. You got your solution right here at 2 comma 3. It's pretty obvious right there. 2 comma 3. X is 2 and y is 3. All right. It even says y is 3 right there. So I mean that's pretty obvious. All right, and guess what? 2 comma 3? 2 plus 3 equals 5. So you take this and you substitute it back and you check. Is 2 plus 3 equals 5? 2 plus 3 equals 5, and the answer is yes. Okay? Okay, next one. We got inequalities. So let's start graphing these. All right, so we got a slope -1 and y-intercept of 5. So we start at 5. And then again, you step it out here, and you have a slope of -1. Okay, it's greater than or equal to, so keep that in mind. So it's going to be solid and above. So let me just make a note of that right here. Okay, solid and above the line, above the boundary line. And so we're going to graph there. So let me graph my function first here. So graph the boundary line, that is. All right, boom, right there. Okay, and this one right here is above the boundary line because of the greater than or equal to symbol right there. That's equation number, or that's inequality 1. Okay, inequality 2. All right, this one right here, this one is going to be dotted in below because it says less than and not greater than. So you start at -4 and you have a slope of 3, which means 3 over 1, up 3, right 1. So up 3, right 1, up 3, right 1. You got to just be careful how you count right there. And then draw your line, of course, as we always do, okay? Now I'm going to draw a line and then I'm going to make it dotted because it says less than, not greater than. So you make that dotted boundary line dotted, okay, because of that. And then you go below, all right? Because as I said, dotted in below. And then where the regions intersect is your solution. So the solution region is here. These are inequalities, not equalities. Big difference. Okay, so you have what's called a solution region. All the solutions are in here. All these points are solutions. Okay, all of them, all infinite number of points in there. Not on this dotted boundary line, but on the solid one, yes. And inside this blue region right here. By the way, those are test questions. We're going to give you points and ask you if they're solutions. So you gotta know that too. I went over that last week. Okay, and now we got to solve by substitution. Okay, so let's do this. All right, x is equal to y plus 7. So you just got to substitute in for x, okay? Or you can take x plus 2, 8 and substitute in for y. It doesn't matter. But you got to substitute. Why? Because it's called the substitution method. So you have y is equal to 8 plus 2 times whatever x is, and up here it says x is y plus 7. So substitute it in, y plus 7. And notice that I put parentheses around the variable here, around x. It's 2 times whatever x is. So it's 2 times the y plus 7. And then you solve for y. So here we go. You're going to distribute through the 2. Here we go. So we have, sound like Yogi Bear right there. So 8 plus 2y plus 14. Okay, 2 times 7, 14. All right, I'm going to add like terms. 8 and 14 is usually 22. So we have y is equal to 2y plus 22. Subtract 2y and gather up your like terms. All right, y minus 2y. 1 minus 2 is -1, so you get a negative y here is equal to 22. And then just, divide by -1 if you like, and you get your y value. Okay, y is -22. Then you take that and you substitute it back. X is equal to y plus 7. So x is equal to -22 plus 7. So x is equal to -15. So your solution here on this system is -15 comma -22. That's the solution to the system. Okay, solved by substitution method. All right. Now let's switch. All right, let's go to the elimination method here. On this one here, you want to find or create opposites. All right, so to do that, I'm just going to say, hey, oh, I see them already. Oh my goodness, look at this. Right there, they're opposites. So all you do is add the equations. All right, easy. I gave you the easy case here. 2y plus 1y is 3y. 10 to -16 is -6 right there, and divide by 3. Okay, and you get y is equal to -2. Then you got to substitute back. So let's use this equation here. 7x plus 2y equals 10. And let's substitute -2 in right here. So we get 7x plus 2 times -2 equals 10. By the way, I just thought of something. All right, you guys are going through this video, and if I'm going too fast, well, you should be pause, playing, and rewind, okay? So go at your own speed. Pause, play, and of course, rewind, all right? And listen to it as many times as it takes to get it down if I'm going too fast. So you get 7x minus 4 equals 10. Adding 4, you get 7x equals 14. If you just got to add 4 there. And obviously 7 times 2 is 14, so x is 2. So your solution is 2 comma -2. There's your solution to the system. All right, and that's the elimination method, okay? Now here I say you can solve by any method, but I noticed here they're both in standard form. All right, and since they're both in what's called standard form, it's really set up for the elimination method. All right, so I'm going to use elimination method here on this one here. Instead of substitution, it's going to be a lot easier. So all I have to do is multiply this first equation by 3, all right, to create opposites. Okay, let me write that down below. So I got 3 times 2x is 6x, 3 times 4y is 12y, and 3 times -3 is -9. And when you add these cancel out to 0, these cancel out to 0, and guess what? 9 and -9, that's 0 too. So you get 0 equals 0, which is true all the time. All right, and that tells me that I have an infinite number of solutions. Okay, so next one, find or create opposites. So here on this one here, I'm just going to see the opposite of 4 is -4. So the only thing I need to do is multiply this one by -2. All right, and that gives me a new equation. So I'm going to put it right below it, line them up. So I get -4x, they're the opposites right there. Just like up here, those are opposites. Right here, these are opposites. And then I get -2 times -3y, which is 6y. And then -2 times 8, that's -16. And then when I add these cancel out, these cancel out, these do not. 14 plus a -16 is -2. And if you look at it here and ask yourself, is 0 -2 equal to -2? And the answer is clearly not. All right, so this is false, which means that there's no solution to the system. Okay? So it's pretty simple. I mean, I didn't have to do much work in order to figure that out. So when the key thing is this, though, you have to know when to use the elimination method versus substitution, okay? Since they were both in standard form, okay, I use elimination because it was easy. All right, remember that. All right, now, last one. So we need to determine if this point is a solution to this system by substituting into both equations, okay? All right, so let's take this and substitute here and then here. Okay, x is -2 and y is -1. So here we go. So 3 times -2 plus 4 times -1, does that equal to -10? Question mark. I don't know. I got -6 here, -4 here. Does that equal to -10? The answer is yes. All right, -6 and -4 is -10. So it's a solution here, is a solution to this one, to this inequality. All right, to the first one, 3x plus 4y is, equation, not inequality. So equals -10. To be a solution to the system, you got to be a solution to both equations. Okay, I don't know, so I got to check it out. Let's do it. So is 2 times -2 minus 9 times -1, does that equal to 4? I don't know. Let's check it. So I got -4 here, I got 9 here. Does that equal 4? And the answer is no. 9 minus 4 is 5. And so it's not a solution here, okay, to this equation right here, 2x minus 9y equals 4. So what this tells me, all right, I have to state my conclusion here, that if it's not a solution to both equations, okay, which it's not, because it's a solution only to the first one, well, then it's not a solution to the system, okay? So I'm going to say that -2 comma -1 is not, okay, a solution to the system, okay, because it wasn't a solution to both equations. Okay, here comes the important part. Because it is not, okay, a solution to both equations. Okay? Let me spell better. There we go. All right, and because of that, it's not a solution to the system. Why? Because it's not a solution to both equations. If it was, I would say it is a solution to the system. Okay, that's version 1. Okay, so if you're version 1, then I want you to practice version 2. So continue with me in the video. If you're version 2, got to go back to version 1. Okay, so here we go. Let's get started on version 1. Excuse me, version 2. So you got a graph. Okay, so start in at 2. Got a slope of 1/2, so you got to go up 1 right 2 and step it out. All right, so we do that. Go ahead and use a straight edge. Make sure you're accurate. All right, next one, you got to start at 5. All right, slope of -1, so you got to step that out too as well. All the way here. And use a straight edge so you're accurate. Okay, solve by graphing requires accuracy. Do it algebraically, well, that just happens naturally. Okay, so here we go. We got looks like 2 comma 3. So does that make sense? Let me see. If I put a 3 here and I put a 2 here, is this true? -2 plus 5 is 3. So you take this and you substitute it back. Okay, and it checks off here. -2 plus 5 is 3, so it works there. And then here you put a 3 here. Is that equal to 1/2 times 2 plus 2? Well, let me see. Half of 2 is 1, and 1 plus 2 is 3, so it checks out there. So you can check it into the system. So check your answer, check the solution by substituting back. It's easy to do that. It's also easy to do this. So check this out. Let's go to y equals here. What's this called? The equation editor here. All right, and let's put your equations in. All right, 1/2 x plus 2. So 1/2 x plus 2. All right, and then go down here and enter in -x plus 5. All right, very simple to type in the equations here. Hit graph and let's see what happens. There is the first function, okay, the 1/2 x plus 2. And here's the other one, y equals -x plus 5. Now let's calculate the intersection by selecting intersect 5, hit the enter button 3 times, and then check it. Look at that. Lo and behold, 2 comma 3. That's where this intersection is. So you check it on the TI-84. Check it on the TI-84 or any graphing calculator you wish. Okay, so I checked in the system, and so I checked it by hand, and I also check it on the calculator. It's like a no-brainer. Okay, next one, I got x equals 5. So find 5 on the x-axis here. Okay, there it is. You go right 5 and go up and down any distance. X is always 5. Okay. All right, that's not true if you go the other direction. You got to go 5 units right there. So there's x equals 5. And you can go up or down. X is always 5 right there. I don't care what point you pick on that line. X is always 5. And that's why they call it x equals 5, guys. So here, you're going to have to solve for y. You're going to have to subtract x. You get -2y is equal to -x plus 5. Divide everything by -2. And you get y is equal to 1/2 x minus 2.5. All right, 5 divided by 2 is 2.5. Excuse me, -2.5. So starting down here at -2.5, you got to go up 1 right 2. So up 1 right 2, up 1 right 2, up 1 right 2, up 1 right 2, and just keep on stepping that out. Take your straight edge out because you're doing it by graphing here, and draw your line. Okay, is that accurate? Let me see. Oh, why did I put 5? Let's redo all of that. Okay, why we're gonna go back in time. I don't know why I put 5. Oh, I know why, because I see a 5 right here. I made a boo-boo. Okay, let me redo that. Come on, Ainsworth here. I'm in a video here, so let's change this. It's 3. I have to write down the right number. So let's subtract x. You get negative 2x, excuse me, negative 2y is equal to negative x plus 3 now. Okay, now we're on the right track. Divide everything by negative 2. There we go. And I get y is equal to 1 half. These cancel. Okay, and you get 1 half x minus, because I see a negative here, 3 divided by 2 is 1 1/2. Now I'm on the right track. So I start at negative 1 1/2, and I have a slope of 1 half. So I got to go up 1, right 2, up 1, right 2, up 1, right 2. Just keep stepping it out. Then draw your line. Okay, so I recovered there, guys. I am only human here. Okay, and what's the solution? Well, let's take a look at it. Let me see the intersect right here. So looks like 5, 1, 5, comma 1. Okay, and let's write it down. Let's check it. Okay, so x is 5, by the way, and that's true. So I know that's x is 5. So if I check it here, if I put a 5 here and a 1 in for y, so I get 5 minus 2 times 1, does that give you 3? The answer is obviously yes, because 5 minus 2 is 3. So you check this, all right, back up here. So you substitute it and back into the system, and you check it, all right? 5 minus 2 times 1 is 3, so you know you're right. Always check your work, because you can't substitute this in, or you can't graph it on the T84, because the T84 cannot graph x equals 5. It has to be y equals something. So basically what I'm saying is that they can't graph a vertical line. Okay, other calculators can, but not the T84. All right, next one. You got y is negative 2, so you got to start on the y-axis here and you find negative 2. Graph negative 2. Y equals negative 2, that is. All right, and also on this one here, you got to solve for y. So let's do that. So you get y is equal to negative x plus 4. So you start at 4 and you slope it out. You got to go down 1, right 1 all the way through. Slope's negative 1, that means negative 1 over 1, which means down 1, right 1. That's why I said this. So, oh, I just hit the line here. So there's my solution right there. As soon as you hit the other line, you know you have your solution, because it's the intersection of the grid lines. No, excuse me, intersection of the two lines. And so what do we have? We have 6, all right, comma 2. It's written like that. So 6 comma 2. And then you could check it, because x is 6 and y is 2. So you take this back and you substitute it in. So sub in, all right, to check. So is 6 plus negative 2, is that equal to 4? And the answer is yes. 6 plus 4 is equal to 6 plus negative 2 equals 4. Oh, I put down positive 2. I meant, whoa, didn't mean to do that. Let me put that line back. I just found a little mistake, because I'm going way too fast. It's 6 comma negative 2, because you went down. Okay, 6 comma negative 2. So I must have been thinking that, because I substituted a negative 2 here. I was looking at the graph. I just didn't write it properly here. So right 6 down 2 is 6 negative 2. And 6 plus negative 2 is 4, so you know you're right. All right, apologize for that. So 6 down, 6 right, down 2, 6 comma negative 2. All right, next one here, we got a couple inequalities here. So let's start at the y-intercept of 3, slopes negative 1, so y-intercept of 3. There's 3 right there between 2 and 4. And then you got to step that out. Now, when you look at inequalities here, you predict what the boundary lines are going to be in advance. Okay, I see an inequality that says greater than or equal to. So right there, I know just by looking at that, it's going to be solid and above, because it says greater than or equal to. So I make it solid, and I determine where the solutions are. Okay, they're on the line and also above the line. So you show that, and you represent that. Solutions are above the line. Here, this is going to be dotted and below, which means the solutions are not on this boundary line, and they are below the boundary line because of the less than right here, the less than sign, okay? The less than inequality. But here we got y-intercept of negative 5, So start at -5 here with a slope of 2. So you got to go up 2, right 1, and step it out. Okay. This one, I'm going to draw the line, and then I'm going to make it dotted. So pull out your eraser, and let's make it dotted, okay? Because it says less than, not less than or equal to. And then it's below the line, all right? Not above, but below. And so this solution here, solution region, is where they intersect. And where they intersect is right through here. This is called the solution region. Or in linear programming, it's called the feasible region. Okay, and that's all there is to it. Now let's do some algebraic methods here. Let's take a look at the elimination method and substitution method. First one, substitution method. Let's take this right here, y plus 3, and substitute it in for x. Okay, put parentheses around it. So I see here y is equal to 2 plus 2 times whatever x is. And up here it says x is y plus 3. So you substitute it in. All right, now you got to solve for y. So let's do that. Let's distribute through the 2 twice. Okay, and get y is equal to 2 plus 2y plus 6. I see some like terms right here, so let's add them up. So y is equal to, not 6, 2 and 6 is usually 8, so you get 8 plus 2y. And then add the opposite here. All right, and we get y minus 2y, which is negative y. And then that equals 8. Divide by -1 to cancel out the negative, and I get y is equal to -8. So that's my y coordinate. The question is, what's x? Well, you take this value here, all right, and you substitute it back. So x is equal to -8 plus 3, which is equal to -5. Okay, so my solution to the system is -5, okay, because I know what x is and I know what y is, right? So I take -5 comma -8, and that's my solution to the system. Remember, it's always an ordered pair, x comma y. All right, now that's the substitution method. It could be done another way. You could have made a different substitution to get the same result, okay? On this one here, using elimination method, it's a little bit different. Okay, you want to find or create opposites. Find or create opposites. Okay, so what we're going to do is I'm going to eliminate y's. Not that you have to, it's just that that's what I'm going to do, because these numbers are smaller than 4 and 7, so I'm going to think before I act. So I'm going to eliminate the y's. To do that, I need these opposites. One's already positive, one's already negative, so I don't have to worry about that. I have to just make sure that they're opposites. And since 2 times -3 is -6, no big deal. All right, I multiply this one by 3. There you go. Multiply both sides by 3 here and get a new equation. And then I'm multiplying the bottom one by 2 because it's already negative. All right, it's already negative. So here we go. Up at the top, 3 times 4x is 12x. 3 times 2y is called 6y. And then 3 times 14, that's 30 and 12, 42. Down here, I get 2 times 7x is 14x. 2 times -3y is -6y. They're the opposites right there, and equals -16. 8 times -2 is 16. And you want to add the equations, okay? Now the opposites add to 0, but the x's do not. So 12 and 14 is 26. So I get 26x is equal to 42 minus 16, which sounds like 26. Okay? And then you divide by 26. All right, you get x equals 1. And then you got to find y. So you got to take this and substitute it back into the original equation here. So I get 7 times 1 minus 3y is equal to -8. And you got to solve for y. So let's do that. So let's subtract 7. And you get -3y is equal to -15. Divide by -3. And you get y is 5. So my solution to the system is 1 comma 5. Always x and then y. Okay? That's elimination method. All right, now on these, you can pick any method you want, but keep this in mind, they're in standard form. And equations which are in standard form are set up for elimination method. So I'm going to use the elimination method on both of these because they're both in standard form. It's much easier. So what I'll do here is just create opposites. So I'm going to just multiply this one by 3, and we'll get a new equation here. So we get 3x here. The reason why I did that is because the opposite of -3 is +3. So you just go ahead and multiply by whatever it takes to create an opposite. 3 times 2y is 6y, and 3 times -1 is -3. And when you combine or add equations, these are 0, these are 0, and guess what? That's 0 too. So I end up with 0 equals 0, which means that I have an infinite number of solutions. Okay, if you don't believe me, you can go ahead and graph these lines. They're the same line, they overlap. And if they overlap, guess what? They overlap at an infinite number of points. And that's why there's an infinite number of solutions here. Now on this one, the opposite of 4 is -4, so I need to multiply this one by 2. All right. When I do, I get uh, -4x here, because 2 times -2x is -4x. 2 times 4 is 8, so I get 8y here, and 8 times 2 is 16. Now when I combine equations here, you got to be careful. These are 0, these are 0, but these are not. Okay, -18 and 16 is -2. And I don't know about you guys, but 0 is not equal to -2. This is false, all right, which means no solution to the system. Okay, that's all there is to it. All right, last one. Okay, here we go. We want to determine if this point is a solution to the system by substituting into both equations. So I need to take this and substitute it over here and determine. And whatever the results I get, determine whether it's a solution to the entire system. Okay, in order for it to be a solution to the system, it has to be a solution to both. If it's only a solution to one, well, then it's not a solution to the system. So I can only conclude after I do a little bit of work here. So here we go. It's 3 times -2 plus 4 times 4. There we go. Does that equal to 10? Well, I don't know. Let's figure it out. So we can get -6 here, 16 here. Does that give you 10? And the answer is yes, it does. So that tells me that our test point, -2, 4, is a solution, all right, to the first equation, all right, to this equation, to 3x plus 4y equals 10. Now it has to satisfy this one too. It has to be a solution to the system, because that's the ultimate question here. So you got to take -2 and substitute it in. So -2 times -2 minus 9 times y, which is 4. The question is does that equal to -32? I don't know. Let's figure it out. So I get 4 here. This is minus 36. Does that give you -32? And the answer is yes, it does. So I know that -2 comma 4 is a solution, all right, to the second equation. So -2x minus 9y equals -32. So since it was a solution to both, okay, here we go. Since, this is where the conclusion comes in. Since -2 comma 4 is a solution to both equations, to both, I'm going to bold this, okay, to both equations, all right, then, all right, our test point, -2 comma 4, is a solution to the system as a whole, okay? Now, not everybody wrote that down. You wrote down whether it's a solution here and here on the individual equations, but you haven't told me whether it is a solution to the system, and that's what the question was asking. It says, determine if a point, -2 comma 4, is a solution to the system, all right? And because it was a solution here on the first one and the second one, then it's a solution to the system. On the previous version, on version 1 here, if you go back, all right, look at this. It's a solution to the first one, but not the second one. And that's why I said it's not a solution to the system. So there's a big difference there. For it to be a solution to the system, it has to be a solution to both equations, not one, but both. Key idea. Okay. All right. So that's versions 1 and 2. And so what you guys have to remember is that if you did version 2, go back and you have to do version 1. All right, so you go back into the video, rewind it, and go practice version 1. And if you do both versions, corrections and practice, I'll allow you to retest when I see you next time, okay? And that's with the conditions. So I wrote them up here. Correct your test first, okay, in red or in your spiral. And then number 2, you got to go through practice all equations in the other version, all right? So version 1 practices version 2. Version 2 practices version 1. Okay, I can't say it any more times than that. Okay, this is Mr. Ainsworth. I'll see you in class. Take care. Bye bye.